Howdy, AP PreCal, it's Miss Kosh. As promised, we were going to talk about finding the slant asymptote. So notice this is top heavy. And what we want to do here, they're telling us to use long division to find the slant asymptote. Whenever it's top heavy, it's going to have either a slant asymptote or a parabolic asymptote or cubic asymptote. It depends on what the difference is between the degrees. Since they're only 1 degree different, then it's linear. So it's going to be a slant. So they want us to use long division. So when I do long division, which we've already practiced, I get a 3x, 6x squared divided by 2x is 3x. And I multiply back, I get 6x squared, I get plus 3x. Subtract, that's a negative 2x plus 5. Negative 2x divided by 2x is a negative 1. Multiply back, negative 2x minus 1. Subtract, which is in essence adding. This is 6. So if you remember, this is plus 6 over, what was I dividing by? 2x plus 1. Well, what happens when x gets ridiculously large? When x gets ridiculously large, we have 6 divided by something ridiculously large, which it's like I have $6 and I share it with the whole world. Well, that was very generous of me. We basically get nothing. I mean, it's not technically nothing, but if I take 6 and I divide it by a ridiculously large number, I'm approaching 0. So this part is not relevant when it comes to what our asymptote is. So this part is. So it says, use long division. Well, so our asymptote is the line y equals 3x minus 1. Okay, so it says, find the equations for any asymptotes. I can factor the bottom to be x plus 6 times x plus 1. So I have a vertical asymptote at x equals negative 1 and x equals negative 6. Sorry, my factored form, what do I get? I don't have enough space. I have x times x plus 6 times x minus 2 over x plus 6. Oh, see, I should factor it first. Oh, let that be a lesson to all of us. That's not an asymptote. That's a hole. So find the equation for the asymptotes. Well, they didn't ask us. I would like to tell you that there's a hole when x is equal to negative 6. So I have a vertical asymptote at x equals negative 1. It's top heavy, so there will be no horizontal asymptote. Factored form is right over there. I should say g of x equals, okay, whatever. And so now I want to figure out what this is going to look like. It's going to look like x squared minus 2x over x plus 1. So with this one, I might actually do a synthetic division and say 1, negative 2, 0, and put a negative 1 out here. 1 times negative 1 is negative 1. This is negative 3 times negative 1 is a positive 3. My remainder is 3. So this is equal to x minus 3 plus 3 over x plus 1. But this will go to 0, and so we're left with the equation of y equals x minus 3. That's our slant asymptote. Okay, well, we're almost there. I'll just finish this up in this video. Okay, which of the following is correct? Okay, so this denominator can be written as, so I have 2x times x plus 4 times x minus 1. The denominator can be factored to be an x minus 1 squared. So this is my d of x, which equals, my bad. So this would look like, let's say this, look like the equation 2x times x plus 4 over x minus 1. So x equals 1 is an asymptote. It's not a hole because the asymptote policy kind of trumps. So x equals 1 is a vertical asymptote. Okay, the graph has one horizontal asymptote. Nope, it's top heavy. So it has no horizontal asymptote. It has a slant asymptote, no holes. Well, we just said we thought it had a hole, but it didn't because it's actually an asymptote. So no holes and one vertical asymptote. I think that's going to be correct. One slant asymptote, one hole. Nope. One vertical asymptote? Nope. Okay, so the answer is D. This one, they want us to go, okay, so as x goes to infinity, we're going to negative infinity. As x goes to negative infinity, we're going to infinity. So what this tells me is that we have a slant asymptote with a negative slope, because as I go to positive infinity, I want to go down. And then we're approaching negative 1. we're approaching -1, and we're going to negative infinity in both directions. And then we've got a slant asymptote that's negative. Okay, and so with this one, we're going to do something like this and something like this. And in order, because we want to go, as we approach -1 from both directions, we're going to negative infinity. As we go to negative infinity, we go to positive for the y's. As we go to positive, we go to negative. That's what it looks like, and I did come up with an equation that would kind of model that sort of stuff. But in order to be doing the same thing in both, you have to have a square, but then since they're both going down, they have to be negative, I think is what I wanted to tell you. I can go look at my equation in just a second. But, okay, what do we know? We know, you know what, let me see what I came up with. Okay, funny. I wrote down in my computer y equal, in Desmos, -x plus 3. I just said it had a slope and it went through 3. And then I said plus -2 over my asymptote was at -1, so x plus 1 squared. So I didn't go ahead and write it in the normal rational function way, but if I type in something like that, let's exit out and clear this mess out. If I have -x plus 3 minus, 2 over, parentheses, x plus 1 squared, that meets those requirements. So I don't have any idea if they're going to ask you to come up with something where they ask you to write the equation. We're still trying to figure out this new AP world. But that's a decent little problem. So good luck. Go practice. Let me know how I can help.